Geometry lesson 5.1, still dealing with triangles, perpendicular and angle bisectors to start with here. When a point is the same distance from two or more objects, the point is said to be equidistant from the objects. Triangle congruence theorems can be used to prove theorems about equidistant points. So there should be a chapter 5a note sheet on Moodle that you can use for this stuff. So if you want to follow along with that, here we go. Perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Meaning, if you know that xy here is the perpendicular bisector, then those two are the same. And the converse is also true. If those two line segments are the same, then xy is the perpendicular bisector. So it's got to cut it in half and be perpendicular. Okay, so if you've got a line and then it becomes perpendicular, bisector, bisector, then that would mean, and I go back here, whoops, sorry about that. So you would have, since this is bisector, bisector, that's a right angle, then that would mean that those two segments are the same, since it's on the perpendicular bisector. Okay, locus is a set of points that satisfies a given condition. So the perpendicular bisector of a segment can be defined as the locus of the points in a plane that are equidistant from the endpoints of the segment. So find each measure. Well, we can see that PN is a perpendicular bisector. So if NL is 2.6, then MN would also be 2.6. BC, well, we can see that these two are the same. So that would mean that AD would have to be the perpendicular bisector. So if DC is 12, then BD would also have to be 12. So BC would be 24. TU, well, you can see that once again, we've got a perpendicular bisector, perpendicular, and then those two segments are the same. So we can set 3x plus 9 equal to 7x minus 17. Subtract 3x for 4x, add 17 to 9, gives you 26. Divide by 4, gives you x is 6.5. Well, I got to plug that back in. So 3 times 6.5 plus 9 is 28.5. All right. All right, remember that the distance between a point and a line is the length of the perpendicular segment from the point to the line. So now we have the angle bisector theorem. If a point is on the bisector of an angle, then it's equidistant to the sides. And then the converse is also true. If a point is on the interior of an angle is equidistant from the sides of the angle, then that line is the angle bisector. So if you've got an angle bisector, then those two are the same. And if you have those two are the same, then that makes that the angle bisector, the converse. All right. Based on these theorems, the angle bisector can be defined as the locus of all points on the interior of an angle that are equidistant to the sides. So, well, we can see that AC is the angle bisector. So to find BC, it would be the same as CD. So it is 7.2. Find EFH given that EFG is 50. So the whole thing is 50. If these two are the same, that makes this the angle bisector. So we would just divide 50 in half to get our answer of 25 degrees. Okay. MKL. Well, we can see that this is the angle those two are the same. So KM must be the angle bisector. So we set 3a plus 20 equal to 2a plus 26. Subtract 2a, which gives me a. Subtract 20, which gives me 6. So a is 6. Plug it back in. 6 times 2, 12, plus 26 is 38 degrees. All right, so using those angle bisector theorems. All right, write an equation of bisectors in the coordinate plane. Write the equation in point-slope form of the perpendicular bisector with the segment endpoints C, 6, -5, and D, -1. All right, when you're doing this, you have to find the midpoint and the slope. And then since we're talking perpendicular bisector, you want to take the opposite reciprocal of your slope and then take that and the midpoint and put it in point-slope form. So let's walk through how to do it. Let's find the slope first. So I'm going to find my slope. -5 minus 1 over 6 minus 10 is -6 over -4, which would reduce to 3 over 2. Okay? But we are perpendicular. So perpendicular to 3 halves, it's -2/3. So we're going to use that slope of -2/3. All right? Then I got to find my midpoint. Okay? Well, 6 plus 10 is 16, divided by 2 is 8. And -5 plus 1 is -4, divided by 2 is -2. These are the things you're going to put into point-slope form to get your equation. All right? So this is on the both assessments here, writing these. So we're going to go y plus 2 equals -2/3 times x minus 8. There is your equation in point-slope form of the perpendicular bisector. So make sure you find slope, take the opposite reciprocal, and then find the midpoint, put it in point-slope form. Let's try that again. Point-slope form, perpendicular bisector. Here we go. Find the slope first. 9 minus 5 over 7 minus -3, which becomes plus 4 over 10 is 2/5. Apotaco, -5 halves. Okay? Then we're going to find the midpoint. 7 plus -3 is 4, divided by 2 is 2. 9 plus 5 is 14, divided by 2 is 7. So people make the mistake of just taking the point and putting it back in. You want to make sure you put the midpoint into that formula. So y minus 7 equals -5 halves times x minus 2. All right, point-slope form of the perpendicular bisector of a line segment.